solving problems for exponential growth and decay questions. This video will show you how to solve problems involving growth and decay type questions. Here is the formula that you will be using. The basic exponential formula looks like this. The final amount is equal to the initial amount times the growth rate or decay to the exponent time divided by period. But what does this mean? A to the subscript final is the amount that is left at the end of the time. A to the subscript initial is the amount you have at the beginning. The growth rate is how much the amount will grow or perhaps decay. If it's decay, it's called the decay rate. The time is the length over which the problem is for. The period is the length of time it takes for one cycle. Now, let's take a look at a problem where we make use of this. A bacterial culture began with 7,500 bacteria. Its growth can be modeled using the formula n equals 7,500 times 2 to the exponent t divided by 36. Where n is the number of bacteria after t hours. How many bacteria will there be present after 36 hours? How many bacteria are present after 72 hours? How does this relate to the doubling time? Now, let's analyze the formula we're given from the example. N equals 7,500 times 2 to the exponent t divided by 36. The initial amount is n, the number left at the end of the time. The initial amount is 7,500, the amount you started with. The growth rate is 2. It's doubling. Whenever you have the word double, it means 2. If you had the word triple, it would mean 3. Since the rate is greater than 1, there is no decay rate. Time, given in the question, is the unknown t. That is what we're trying to solve. And the period, 36, is the number of bacteria, doubles every 36 hours. This is the length of one cycle. Now, n, what we are trying to find, t, we have that given in the question. If we look at A, it's over 36 hours. Substitute into the equation. N equals 7,500 times 2 to the exponent 36 divided by 36. Well, we know that 36 divided by 36 is 1, so n would be 7,500 times 2 gives us the final answer, 15,000. There are 15,000 bacteria present after 36 hours. Now, what about part B? In this part, we're given time over 72 hours. How does this change our calculation? We substitute into the equation. N is equal to 7,500 times 2 to the exponent 72 divided by 36. 7,500 times 2, 72 divided by 36 is 2. 7,500 times 2 to the exponent 2, which is equal to 30,000. The number of bacteria present after after 72 hours is 30,000. Now, here is a second example. All living organisms contain a known concentration of 1 part per trillion parts of carbon-14. Carbon-14 is a radioactive element. It is used to date ancient artifacts because it has a half-life of about 5,730 years after the organism dies. The formula we're given for the question, C is equal to 1/2 to the exponent n divided by 5,730. What would be the concentration, C, of carbon-14 in a piece of cloth made from plant fibers after 5,730 years? What would be the concentration of carbon-14 in an animal bone after 50,000 years? Round your answer to 5 decimal places. Now, let's analyze the formula. C is equal to 1/2 to the exponent n divided by 5,730. A final is represented by C, the final amount, C, the number left at the end of the time, the amount of carbon left in the sample. A initial is 1, the amount you started with. We don't actually see the number 1 at the beginning in front of the 1/2, but anytime you have 1, it's understood to be there. So we say this is indirectly given. The growth rate. Since the rate is less than 1, this is a decay question. The decay rate is considered a half-life, 1/2. Time, given in the question, is the length of time over which the problem is for. The period of 1 half-life is 5,730 years. This means that after 1 half-life, 5,730, you have 50% of the carbon left if you started with 100%. Now, let's find the solution for part A. C, what we are trying to find. N, we're given in the question 5,730 years. Substitute in the equation. C is equal to 1 times 1/2 to the exponent 5,730 divided by 5,730. Solve. C is equal to 1/2, and we now have the exponent of 1, so C is equal to 0.5. After 5,730 years, the concentration of carbon would be 0.5 parts per trillion. Now, here's the example, solving for part A. C is what we are trying to find. N is 50,000 years. Substitute into the equation. C is equal to 1 times 1/2, 50,000 divided by 5,730. Use your calculator. You will get C is equal to 0.00236. After 50,000 years, the concentration of carbon-14 would be 0.00236 parts per trillion. Excuse me, that should have been part B. Now, continue to the next part of your lesson.